Thanks, Merlin. It's really good to be back with Crux again. The name is Kevin Keogh. I'm the president and CEO of Evergold Corp, and we explore for precious metals in British Columbia and Nevada with a particular focus on north central British Columbia at the current time and our Golden Line property in particular.
Kevin, thank you for the introduction. Nice to meet you, so to speak, over the dreaded Zoom, and hopefully I'll meet you in person one of these days.
Hopefully, indeed, yes, at long last.
You're back into in-person meetings, mixing it up with Zoom, I believe, at the moment.
Oh, we are, yes. Some of the shows that have been long delayed and had gone virtual, which I never found all that effective, are going back to physical. So we'll be starting that cycle again next week, Merlin.
Excellent. Well, I also see you've just put out a news release this week talking about your plans, the drilling plans for Golden Line this summer. However, yes. Could we just kind of backtrack and could you just kind of provide some context to this, to the property, to the Golden Horseshoe? I think let's start there, if you could.
Yes. Well, sure. Evergold as a corporation is relatively new. It was founded in 2015. But we actually parked it for a number of years because we were focused on another company of ours called GT Gold Corp, which the long and short of it is we delivered a major discovery from and we sold it out to Newmont last year. So with that out of the hopper, so to speak, I had been busy reactivating Evergold, and we've had a suite of really good assets. And of course, we're never quite sure which one's going to really pay off. We've done some work in 2020, 2021 on several of those BC properties, Snowball and Golden Line in particular. And to date, I'd say we've had the best traction on our Golden Line property. And just at the close of last season, 2021, we delivered the highest grades we've ever found on that property at the GL1 main zone, and it is a game changer. This happens to be a pretty hot emerging, or I might say re-emerging area. It's called the Toodoggone, and there are a number of other companies near us, Thesis Gold, A-Mark as well to the south, Newmont, or not Newmont so much as Benchmark and Freeport are all active in the area. So it's a re-emerging field or re-emerging play.
Well, when you say re-emerging, when did it first emerge? I mean, hasn't Centerra got the Chemes mine up there? Isn't that part of the same belt?
Yes, they do, but that's further south. It's a sort of southern Toodoggone. The Toodoggone was known principally as a high-grade precious metal area. There were a number of small mines. One of them, the Cheney mine, operated by the French. This was back in the 1980s, 1990s. Okay. The Shasta property owned by TDG Gold at the minute, Baker Mine. And so there are a whole series of these small operations. And I think some of these companies now are really looking at developing much larger plays out of what used to be some of these isolated high-grade outcroppings. So there's potential for large open pit and potentially underground precious metals mines. Centerra is mainly focused on a porphyry play well to the south.
Mm-hmm. Okay, and I've seen in your literature, and I've seen in Benchmark's literature and Thesis Gold's literature, kind of talks about low sulfidation and high sulfidation epithermal deposits. And right. I guess what you're looking for is a large, high-grade, open-pittable resource. I mean, everybody is. But just to put things in context, the Lawyers project Benchmark, that's about 3 million ounces at around one. The global resource is about 1.5, 1.6 grams per ton, but actually the in-pit resource is around 1.2 grams a ton. So that's the kind of the open pit target. And then just further south, I think it's Thesis Gold at Ranch. They're picking up some very nice high grade results. including, I just saw, they hit something called, they're calling Bonanza, and why wouldn't you?
Yes.
They got 34 meters at almost 20 grams gold.
Yes. Yes, those two plays, the ranch property, Thesis's ranch property, and Benchmark's lawyer's property. Benchmark's lawyers used to have the Cheney mine on it, which was the one I mentioned operated by the French long ago. They clearly have bulk tonnage potential, but they also have very high grades locally. So it's a question of what you want. I think in the case of Benchmark, it's going to be a big open pit, but people shouldn't lose sight of the fact that there are real high grades in there too. And Thesis, we'll see how that evolves. They've got a whole complex of nice high grade targets to go for, shallow, good topography, and it could be a combination of open pit and underground there eventually. And that's kind of what we're looking at Golden Line. Thesis and the ranch property is right up against us. And by the close of this season, we'll be able to drive to within about 10 easy kilometers of our Golden Line GL1 main prospect. We just have to go up a gentle mountain valley from Thesis's road access point. And I might mention back in the early 80s when Newmont held our Golden Line property, and they clearly saw large-scale potential in Golden Line, they actually tracked a bulldozer up to Golden Line. And so, the access is improving rapidly in this area. What's unique about what we've got is I would suggest that Golden Line and our GL1 main prospect, the one we got the high grades from, as a standalone single prospect, it's probably one of the very best, if not the best, target in the Golden Line, or at least in the Toodoggone camp at the minute. It's got large scale potential. It's got both bulk tonnage style, shallow, and it has that emerging high grade potential, which might lead us into the underground at some point.
I didn't realize that Ranch was right on your southern boundary.
Yes.
Have you got a map that you could just kind of help me with my orientation?
I do. Let me go there and I'll bring up this is our Toodoggone map here. So can you see that here?
Yeah, yes, I can.
Yes. On the right.
Toodoggone.
Yes, so that's the Toodoggone mining camp that we're looking at here. And top in red is Evergold.
Yeah.
Just below it, it's not so clear here, but all of that light purple is Thesis's ranch, which butts right up against our property on the south.
Okay. Yeah.
To give you an idea, it's about you can see the Thesis ranch camp from our GL1 prospect. It's that close. So down here is Benchmark Lawyers, big property. TDG Gold, Shasta here, and they also own the property immediately to the right of us or to the east of us there. And you can't see many of them, Merlin, but all of those little, pickaxe marks all over the place. There are a lot more. Some of these historically, like at Thesis, for example, some of their deposits were actually mined and processed down at the Lawyers or Shasta at the Baker mine there. So it's a hot little area, and I might point out, you see in the same map, it's probably invisible almost to you, but in the lower left corner, there's an inset with BC, and you see the little golden horseshoe. That kind of promotional term, the golden horseshoe, has been developed in the last couple of years by some of the players in this area, because what it really is trying to do is link the geology of the Toodoggone camp to the well-known Golden Triangle, which is over to the west of us. It's actually the same or very similar geology. It's the Stickeen Arch, and the Stickeen Arch arches up just like that horseshoe does. And so we're basically at Toodoggone, we're on the east limb of the same rocks that host the Golden Triangle.
Right.
So there's that geological link, and it is hot geological real estate.
And when you say kind of an arch, is that like essentially an anti or synclinorium, or a kind of just a kind of a crustal scale fold structure that's exposed both in the Golden Triangle and down that eastern limb?
Yes, there's actually a major basin between the east and west limbs there. It's called the Bowser Basin. And it's mostly dead sedimentary rocks that have been piled on top of the back arc volcanics that comprise the Toodoggone as well as the Golden Triangle proper to the west. So on our property, and that's in common with, lawyers and thesis, of course, you basically got volcanic clastics, basalt, andesites, coupled with intrusions, granodiorite intrusions, quite a bit of faulting going on. You might notice over at thesis, they have a lot of faulting and cross faulting. What's intriguing about Golden Line and the GL1 main zone is it's quite continuous, the GL1 main zone where we've drilled it. We don't see evidence of displacement along this long structure, and the structure is at least 6 kilometers in length where we've traced it across the property, and it doesn't seem to be displaced along that 6 kilometers to any significant degree. In fact, to any degree at all, which hosts, that actually holds out the prospect of, an easier development play, shall we say, if we really get stuck into what we think could be there.
But I'll come back to that, because I did, when I was looking at some of your geochemistry, I did think that there looked as if there were some kind of structural orientations within that, but that could easily have been a lithological feature as well. But tell me a little bit about what got Newmont in there, and did they do it? I know you said they had a bulldozer track in there, but were they effectively heli supported, and what was their campaign? Because Newmont owned it in the 80s, is that right?
Yes, they did. They drilled it in 1984, and they advanced it to drilling in the prior year or two. What got them in there was geochemistry, sampling, some regional sampling, I believe, by the BC Geological Survey that had turned up some numbers. Then they did a lot more, and that developed a very promising looking gold, silver, lead, and zinc target. They believed epithermal in style, and went in there. And no, it was not heli supported, Merlin. It was entirely, at that point, let's call it track access. They used a JCB and a bulldozer basically to get up there, and they dragged the drill up there, and they basically dragged the drill around doing it. And they did a lot of trenching, by the way, as well. So they proved there was something significant there, because they had a kind of shotgun approach to the drilling they did. They drilled about 22 holes, 2,500 meters of drilling. It was all this narrow BQ diameter stuff. They often had very poor recoveries. And where they got the best results was clearly at GL1 main, and they drilled this GL1 main zone along about probably 1,000 meters of strike, at the southern end of which they got very high grades of silver. I've summarized those myself, looked at them closely. There are very high grades of silver. I'm talking, 500, 900, even. We've personally sampled over 10,000 grams per ton silver in outcrop at the south end of the system, which we haven't really talked about much. So this is what Newmont got, but at the core of the zone, which we're focused on now, the GL1 main zone, they consistently got these broad intercepts of bulk tonnage style at surface. For example, 87 or 90 meters of over a gram material. And this was right from surface. They didn't seem in their individual samples to get any significant high grades. They didn't, actually. I think the highest single sample they ever had from Newmont was about 7 grams. But there were some shortcomings in the program. For one thing, they didn't do a single undercut on from any of their pads, So and the holes were all widely spaced. along several hundred meters of strike, as I mentioned, and they were kind of trying to figure things out. They believed it was dipping one way and the other. Anyway, they didn't do any undercuts. So when the property, they did that work in 84, the gold price was declining after that. Eventually, they let it go. It sat. A number of other companies, Entourage and others, did work on it in the latter 1990s. And then it kind of sat. We picked it up, or the vendor to Evergold picked it up in 2013. And we did quite a bit of work between 2016, 17, 18, and mainly prep work. In 2020, we drilled it. And I might say every hole we put in at GL1 main consistently got these broad intercepts of bulk tonnage style from surface. And we didn't really know exactly what we were doing either, because we hadn't figured out the geology yet, dips, etc., strike, plunge. We did do a lot of geophysics too, though, and it suggested to us that this thing was probably getting sweeter, deeper. So we went there.
Sorry, what geophysics did you do?
IP, actually, ground-based IP, and quite a lot of it. Yeah. So and we also did detailed magnetics. So we developed a sense from that, which we talked about publicly, that it appeared that this system was likely getting sweeter just below where the historical drilling had occurred, including our own drilling. And we went back last year, 2021, with the goal of testing that. And I might say it was successful, maybe in ways that we didn't anticipate, as is usually the case with geology. For example, we struggled a bit with last year's program because we had COVID-related labor issues. Yeah. Basically, the drill was only on site for 4 weeks. We lost the drill crews, and we just barely got done some of what we were hoping to do. And but as luck would have it, the final 3 holes of the program delivered the highest grades. I'm talking high individual grades exceeding 30, 40 grams per ton, grades of silver of over 900 grams per ton. These are I'm talking about single samples. Within these considerable envelopes, 11 meters of 5, 6 grams, 40 meters of 2 grams, this kind of thing. So we got really encouraging results, basically found the first high-grade domain. And what was surprising about it is it actually it's not just deeper, it is deeper too, but it comes right to surface between some of the historical drilling. So we now think that not only is it a broad, long epithermal system with the typical high-grade chutes and bulk tonnage envelopes, but we believe there's a plunge direction to that mineralization. So,
have you got a map of this? And
I do.
It'd be good. I'd like just to have a kind of a look to understand. You mentioned a 6 kilometer fault and a 2.7 kilometer geochemical anomaly and various other numbers with lengths and distances. I'd like to see it in plan if possible.
So this is a plan view of just, I'll show you the step back view of the system later, but this is just a plan view of the core area we've been focused on. So this is GL1 main. Can you see my cursor moving there?
Yes, I can.
Yeah, so that's GL1 main. That's about 400 meters in length, that area. So what we've discovered, of course, we've done a lot of modeling, and a lot of that happened through last winter as well. But you notice I have a number of arrows on there, right? Okay, so there's a major fault. The light dashed line that I've got my cursor going along, that's a GL fault, right? And that's a major contact. You've seen that before at places like Great Bear with their LP fault. It seems there's so often an association of the mineralization with a major structure. And we had that major structure. And it's that one that I was telling you about. We traced for about 6 kilometers along strike here. And the strike is generally northwest, southeast. Now, along that strike, it appears, or in the vicinity rather, of the GL1 main zone, most of the strata, and this is volcanic rocks, basalts, andesites, and some volcanic, quite a few volcanic clastics, tuffs, that kind of thing. It actually generally dips to the southwest as per this arrow down here in the bottom center. And that's fairly shallow to the southwest, the dip and strike of the strata, right? Maybe 35, 40 degrees to the southwest. What's interesting is it appears that this fault, and take this with a grain of salt because we don't fully understand it yet, but it appears it's actually the contact dipping to the northeast. And the GL1 main zone itself is dipping to the northeast. And we believe that's the case at the current time. But within that dip to the northeast, which you can see up here, zone dip, we believe now that there's actually a plunge on the mineralization within that planar feature. And that the feature here, we think there's a series of kind of intrusions along the fault, ignimbrites and that kind of thing, next to the granodiorite. They've come up along the zone of weakness, and it's kind of in those bodies that we're getting this hosted epithermal style mineralization. So the whole thing, if you envisage a plane, if you go down a little bit here, to the south, I'm just going to try to move this. You see this image within the inset here. This gives you a sense, right? That's the zone, and again, that's the zone dipping to the northeast. It's much broader than that, but we've just put it in so you can see the planar feature. That's actually hosted within these subset intrusives, or that we don't fully understand yet, but the strata is dipping the opposite way down to the southwest there, right? So within that, we have a plunge direction on the chutes, and if you follow my cursor here, that direction we believe is actually down to the northwest. So it gets complicated, but you see this phenomena often in these epithermal systems where you'll have a strike and a dip to the overall zone. But within the zone, you can have the juicy goods coming up at an angle to that, kind of raking, they used to call it in the old days, you know. So that's where we think things are going actually within the system, down that way. So just moving to the next slide, which slide 13 here, this is a long section, and this long section, just going back one again, that long section I'll show you is from the northeast here down to the southeast on this slide. Yeah, so this is just, you know, if I was to put a big arrow, you see over in the left plunge direction, right? I mean, my preference in a way would be to put a big arrow on this thing, big, much bigger than that. It's plunging down to the left corner, that similar direction to the small red. We think we clip the top of the system up here to the top right where the trees are, for example. But bear in mind, we don't fully understand anything yet. But it's looking very encouraging. I'm just going to get out of the let me come back here for a minute.
So when you talk about that plane, you had the faulted contact with the intrusive rocks over here, and then the volcanics dipping a different direction, but kind of cross cut through that, and then sub-parallel to that, but within the volcanics was a structural zone which has got the mineralization. Or do you think that it's actually on their contact, or is it?
Yes, it's up against the contact, actually.
Okay.
Yeah. So and you might think, Merlin, along that contact, that so you've got these major intrusions just outboard to the contact, like the granodiorite, for example. But within the contact, zone, shall we say, or proximal to it, you've got these dike. We're not sure they're dikes, but they're intrusives of some kind that have come up along that zone, and it's within those that you're getting this hosted mineralization. I will just see if I can step back here and give you perhaps a broader view of.
And what gives you the feeling that this is an epithermal? I mean, can you see adularia? Can you see, I don't know,
Yes.
phyllic alteration? Can you see quartz sericite pyrite assemblages? What gives you the confidence? And I know that you're at the early stages of discovery, so I'm not going to hold you to anything. But what leads you in that to that way of thinking?
Well, I'll show you here again, just on the. Let me move things around a bit. Here's a good shot of one of the intercepts from our. And let me just get over to the current slide. Pardon me.
Thank you. That's great. Oh, I've got a bee crawling up my leg.
Oh, that's no good. This is a shot from of a full box, actually, of the typical alteration that we get at GL1 main zone. And this is from hole 24. You can see that indicated up there on the left, Merlin.
Yeah.
Don't be confused by the kind of pink look here. We thought nearly going that might be potassic alteration, but it's not actually. It's iron carbonate.
Right.
So there's a lot of quartz and a lot of carbonate in there. There's some of the carbonate. There's quartz all through here, and there's iron carbonate and various other types of carbonate in here. And you get your typical association of sulfides. We've got a lot of sphalerite in here, pyrite as well, galena. That's where we're getting, of course, the lead and zinc credits from. And I might say there's a lot of zinc and sometimes over 10, 20% zinc in some of these single samples we're getting, similar values of lead. So it's kind of got some unique features that way in comparison. It's got, but clearly we need to see the high sulfide content in order to get the high values of gold and silver, I might add.
So this GL24, this is where you got 3 meters at 11 grams, wasn't it? In that photograph, more or less.
Yes, actually, and this is some of it. Let me just scoop back. No, in fact, pardon me. There we go.
There it is.
That's from hole 24. We actually quite a few of these sort of massive or semi-massive sulfide intercepts like that. So this gives you the high gold and the high silver, and often you get the two together in that kind of ratio that I mentioned before. If it's really, really high sulfide, you can get hundreds of grams of silver, coupled with something on the order of 20, 30, 40 grams per ton of gold. Now, I mentioned before, and I have another presentation that I'll come to, but I'll just focus on this section view here. This is actually drill section 23, 24, 25, Merlin. This was the last 3 holes drilled last year. Mm-hmm. This is what gave us the first high-grade domain. And I might point out, as I suggested, that these intercepts up here in hole 24 are actually just 20 meters from surface. It comes to surface basically here. So you can see the blue histograms there, that's the silver, and the pink, red, that's the gold, right? And you see the association generally between the two. We're going to go back on that pad immediately, actually, with the planned program that's coming. And we're going to put one more hole in. You were asking about where that fault, you see the fault there? Mm-hmm, mm-hmm. That's then the granodiorite. So this is the package of trachyandesites and various other, we don't fully understand the rocks yet, but it's basically, we need to understand where that fault is going at depth. We don't know that yet. So we're going to go back on this pad, which is still in place, and drill further down this way.
Is it difficult to see the geology in those trachyandesites? I'm not even sure I can remember what a trachyandesite is.
It is difficult to some degree to differentiate, and I'm not the mineralogy expert here, but these tend to be some of these are almost porphyritic in appearance, but they're not. It's not an intrusive that way. Ignimbrites and all. To the lay person, you probably couldn't differentiate between the two, but there do tend to be coarse bladed crystals with a very fine ground mass surrounding these crystals in all these rock types here. How do you know when you're in the good stuff? Is it just the sulfides, or is it the veining? Is it the carbonates? It's a combination of the alteration. Yes, that is the quartz carbonate alteration, sericite, some of the other alteration minerals that you get, and yes, the sulfides. Then you really know you're in it.
And do you need the intrusive? Do you need these kind of dike-like features? I'm just trying to work out what are your exploration tools here? Is it the orientation of the Can we jump away from the screen for a second? I mean,
sure.
The sharing. I'm just trying to work out. You've got the main zone, and you're obviously going to be testing your extensions along strike, along depth with a bit of infill. Mm-hmm. But to understand, and you'll learn as you go through that process. But to understand how. What's your targeting method at the moment? Let's say you were going to do a step out.
Yes.
What's driving you?
Well, at a really step back level, we of course have discovered we've determined that the magnetics, for example, the detailed magnetics seem to show an association of the known zones of mineralization with the magnetic lows, and this is a phenomena that you'll see at Thesis. They've clearly got an association down there between what they drill, and maybe you're not surprised by that, with the destruction, magnetite destruction, et cetera, that goes on with the alteration in these systems. But it's going to be more complex. And we can see, though, from the magnetics that we've got a system, i.e. magnetic lows that extend a long way along strike. And in some cases are going different directions. So we got that broad picture. IP as a tool has given us, you might suggest that the resistivity highs are associated with the best of the mineralization here too. It's not quite, we do get a bit of a chargeability signature, but the resistivity is something you want to look after. But if you zero right in, I don't, as far as exploration tools, the best tool we've got right in close now is the drill. And it's really a question of just systematically stepping out, maybe not too aggressively at first, because, you might recall with our major saddle discovery, Merlin, a few years ago, we focused on 50-meter step outs in the early going till we really understood more about that system. And then you can step out further beyond that. So right now, I pointed out that we have what appear to be developing plunge direction. We want to be in that plunge. We want to follow that plunge. And that's probably to the north-northwest. It's going down. But bear in mind that it may well be the case that the footprint of the system is even stronger looking than we've been led to believe, because immediately north of GL1, there's been a lot of slumping off the hillside. We think it's covering the system. The geochemistry, for example, which was a very helpful tool to us and continues to be, it's kind of weak immediately north there, and then it really picks up again up on what we're calling GL1 North Ridge. So,
okay.
Yeah.
Interesting. And you've obviously got let's say this is, I've got a ruler up here as a nice demonstration tool. If that's your plunge going down, You don't know yet how wide that plunging zone is because it's very early days in the drilling.
Yeah,
so
typically you might think of the mineralized fluids have come up in complex ways, right? And within the planar feature, shall we say, and maybe it ends up not being as planar as we think. Maybe it does odd things, right? It usually does.
Yeah.
But let's say it's going down this way. Within it, you're getting finger-like fluids coming up at an angle within that plane. And it's that's where you kind of got to go. Years ago, I was involved with a company called PC Gold, and we had the old Pickle Cove gold mine. And the old timers, they mapped out their structures from surface to over a mile depth. That was a really deep mine. And they did a beautiful map in which they mapped out the chutes, the actual high grade chutes within that kind of roughly planar feature of the big sheeted vein systems. And it was like a zebra, you know, you could see the structure, the planar structure of the vein itself. And within it, you had all of these chutes going down at an angle within it. So you probably have something similar to that going on at GL1 Main. And
as well as that, though, I mean, you will want to, of course, define your let's call it your GL1 Main plunging chute, but you'll also be looking for repeats.
Oh, absolutely. It's not as if this is going to be a single, it's not going to be a single chute by any means, Merlin. And maybe a chute in a way is simplifying it too much. There's got to be continuity laterally and to depth within the system. So, you know, it may be weaker in some places, stronger in others, but that general direction is where you want to be. And I want to find, if I can, and I will show you a plan view. Just wanted to give you a sense of where the scale potential. I will share another one with you right now, if you don't mind. I don't.
No, that'd be great. Also, what's the cover like there? Have you got good exposure? Can you map at surface?
Well, the exposure is good, especially along the ridge tops, but not so good maybe down on the slopes. And I will show you what I mean by that in a minute there, Merlin, but because there's some good photos we have. You can see this slide now, right?
Yeah.
Okay, so pardon me, what happened?
Can you sorry, I'm being greedy. I want to see it in full screen.
Yes, just let me go back to that. I think I accidentally got out of where I was. Okay. All right, there we go.
This is the one I thought had structural grain on it, but I'll be quiet and let you explain it.
Yes, so what you're looking at here is simply the gold and gold in yellow, red, orange there, and the silver in tones of blue. Geochemistry, right? And you're looking at a fairly long 2.7, almost 3 kilometers of strike length there. And as I mentioned, that is, I don't have haven't plotted the fault there, but the fault itself is much longer than that. And the geochemistry hints of it is much larger than this view too. But so this is simply the geochemistry, soil, gold and silver on topography. You'll notice here at GL1 Main, it's the part that's circled, or not circled, but rather got the rectangle in black around it. You notice that that's where the best of the drilled system is to date. These other areas along strike basically are untouched or mostly untouched. And you'll notice this at an angle to it, this lovely gold anomaly here. We now think that actually is a bit misleading. We drilled that a couple of times. There's nothing there. We think it's reflecting transport down from upslope here. So basically, it's transported the anomaly down. This is where you want to be. Now, you notice the geochemistry is weak here, just north of the rectangle, right? That's as well, we think, because there's slump structures along the edge of this ridge that's all covered by material. So we think the system just continues here. This is a very strong gold anomaly up here. We put a single hole into it. We think we drilled it the wrong way, but the system is clearly continuing up ridge and up to the north. It may split and go off to the west. We don't know. But on the southern end here, I want to draw your attention to that, Merlin. Up on this ridge here and this really strong dark blue, this is where we've got some extraordinarily high values of silver in outcrop. This is and we announced these results as well in previous news releases. We get up into kilograms of gold. Not gold, I'm sorry, but silver. The values are really strong in outcrop up here. And we're going to be doing some work. We think this may reflect a zonation effect. So you get strong silver here. We noticed down at GL1 main in the drilling we did do that there's sometimes you get silver only hits that appear to be outboard to GL1 main. Although at GL1 main, you get the combination of silver and gold outboard. So we seem to see a zonation effect, and that's possibly exciting because we think that, for example, with this tail to the south here of high silvers, that may reflect the system again dipping down to the northeast, and beneath this ridge here is probably where the gold, if there's a zonation effect, the gold will be down dip beneath the ridge.
Okay, thank you. That's really interesting. In your news release from the 9th of May, you talked about doing 2,200 meters of drilling in your phase 1, middle of June to July, and then going on to do a phase 2 potentially in August, September.
Yes.
How much of that is going to be within that square box that was kind of the GL1 main zone, and how much of it is going to be testing the ridge line for silver, the south and north? What's the split? Initially,
we haven't determined where all the potential 2,100 meters is going to go, but I can tell you that the initial holes are going to focus right in there around the high-grade domain that we've turned up. So that'd be section 2.3, 2.4, 2.5, those holes. We're going to step out. We're actually going to step down on that section deeper, and we're going to step lateral to it, probably 50-meter step outs from new pads, and try to get a better understanding of the plunge direction on that particular high-grade domain. And from there, we will determine where we go. Obviously, if it looks good, we will just continue to step out and try to hit wherever we think that high grade. And we don't need to wait for assay results, Merlin. We understand now visually what will give us the high grade. So it's a question of just doing the work. We have XRF that we can use in the field as well as a backup tool. It gives us good readings, for the lead and zinc and silver, not the gold though, but we know where to go. We can do it visually. And I might add, as far as step outs, I can tell you we're certainly looking at planning, for example, a high-grade test of the silver potential upslope to the south along that silver tail, so to speak. That whole area could open up with some drilling quite significantly. Yes, I can tell you historically Newmont did put a few scattered, very shallow holes up there. These were like 50, 75 meters deep, BQ diameter, bad recoveries. And in several of their holes, they got multiple high grade, 16 ounces per ton, 20 ounces per ton silver. With, funny enough, in one of those holes, they started to pick up gold as well, like 0.2 of an ounce. So it's got tremendous upside. So we'll stick with the knitting in the early going, and we will expand. We'll just try to keep hitting and stay with the high grade. And if that initial phase of work looks good. We'll try to expand the program. I can tell you that we have planned holes that could take us to over 10,000 meters of drilling this summer if we extend out into September. So it's got considerable potential. And, you know, people have to understand, look at what I think Thesis announced today, right? I mean, they're drilling 50,000 meters, 50,000. I mean, these are the sort of numbers that you have to put in on these high grade systems to really prove them up.
Yeah, well, that's the target, isn't it? You want to find another lawyers, another Thesis. You know, those two companies are trading at $100 and something million, $160 million Canadian. You're
Yes.
trading at under $8 million Canadian. So that's the path that you want to tread.
Yes, and I think I'd emphasize we have something very real. It's not as if it's all a hope machine at the minute. It's not just a hope machine. Of course, we hope for a better, but we already have a big system, drilled system. It's got broad, open pit styles, potentially at surface. When you talk 100 meters of 1 gram material sitting near surface or at surface, that's really encouraging. We've got this potential strike length, moderate topography. I think you asked about that as well. And I would like to show you perhaps one other shot here, Merlin, if I can.
The concluding shot, a parting shot.
Does not seem to be working. I wonder what's gone on. Anyway, what I would encourage people to do is simply go have a look, and you probably have that handy. If they look at the visuals, the last slide of our February presentation, they'll see a shot of the GL1 main zone, the drill, and the drill's actually set up on holes 24, 25. In fact, I think it was drilling 25 in that shot. You can see a drill pad in the distance as well. That's actually GL1 main, and you can see it's quite moderate, the topography. It's grass covered. And as I said, if this develops rapidly into something significant, the access to the property, to the site, is very good by BC standards. We simply need to push a road or a track back up from Thesis, from their road, and we'll be at GL1 main. So it's a lovely prospect, both from an exploration and potential development standpoint.
Great. Can you see the picture now? I think I've got it up on the screen.
Let me... No, I'm sorry, but it's one of these glitches that I have with Zoom going on at the minute. I can no longer even see you, no matter what I do here, Merlin. So,
well, I'm going to wave goodbye to you, and Kevin, say thank you very much. It's been a really interesting introduction to the property and the project, and to the company. And good luck with the marketing as you go to the conferences now. Hopefully, see you at PDAC. If you pop up there.
I'll definitely be there. We'll have a booth, Merlin, so I look forward to that. It's great to be seeing people in person again.
I'll come around and shake your hand.
All right.
And I look forward very much to seeing the news flow from Goldline over the summer.
Yes. Okay. Thanks very much, Merlin. Any further follow-up questions, just let me know.
Will do. Thanks a lot.
Take care.